Now let us perform some functional tests. For counter objects, we know that their count can be queried and set with the respective messages. The simplest test increases the count by 5. The result was 5. Repeating the test, the result becomes 10. Going back to the component, it actually shows 10. Now we want our test results to be the messages success or failure. This test increases the count to 10,000 and then decreases it 10,000 times by 1. Success means that the result is the same value that we started with. But is it true for multi-threaded applications also? When we perform this test, we receive the result success. We now select a test that performs the decrement of the count in a different thread. It is basically the same code, but it includes a call to fork the decrementing process and some code to also display the computed result. This time the result is failure. Now let us modify the test in that we allow a delay of 1 millisecond to give other threads a chance. The result is success once again. Now let us select the entry LX, which opens Query Vision and activates the halos. The Query Vision main screen shows diverse Seaside components, and we see their names in the halos. As always, we can perform tests for each component. How about the component LX mainframe? Inspect Test opens a Flipper inspector to explore the component in the Smalltalk image. Tests can use any Smalltalk syntax where the expression self stands for the selected component. With browse class of the object, we inform ourselves about the messages the component understands. For example, we see the method #components, which we will use in the following. We want to write a new test for the LX mainframe component. To do so, use the link below the test list to create a test and give it a descriptive name. These Smalltalk statements test if LX mainframes can contain subcomponents. This test is not only important for LX mainframe components, but for each component of which we might expect that it could contain other components. When we perform the test, the result success is shown, meaning subcomponents are possible. If we want to make sure that an LX mainframe contains at least one component, at the moment we can declare it in a similar way. The same test name is still selected, so to perform the test we just have to click on Update. Again, the result is success. Assuming we expect that a mainframe component always contains more than 2 subcomponents, then the test returns failure because this mainframe does not satisfy that condition. In conclusion, we can summarize that Halo tests 2 can contain syntax of any complexity. The third possibility our test suite offers is a proxy server which can test any web application. We can record the client requests and server responses and later analyze them in a parsed tree. Also, a playback mode is prepared that can re-evaluate client requests and test if the server's responses are still consistent. Let us begin by opening a Seaside server in a Dolphin image and take a look at if it is running in a web browser. Now we change the proxy settings in our web browser so that the browser no longer contacts the web app server directly, and then start the Squeak image in which we installed the Testsuite proxy server. As an example, we again select Seaside's multi-counter. The proxy server manages lists of the client's requests and server's responses. Let us delete those. Then we browse a bit to fill the proxy's traffic lists. The list traffic shows both directions simultaneously. 5 requests have been issued by the browser, as we can see, and the server's answers follow those entries. Requests and responses can be unfolded in a tree structure, and the collected data is shown in parsed form. Parsed means that everything we see here was split into Smalltalk objects, and this means that we can use Smalltalk expressions to define tests upon them. To put it in simple terms, everything that has happened between client and server can be tested this way. To do this, Smalltalk statements are used to navigate through the tree and make queries at the points of interest. Let me browse through the tree to find some simple but interesting examples. This place is interesting in particular because in this node the whole HTML DOM tree is hooked into our tree. For example, in the subtree head, we find the title of the page. And in the subtree body, there is a counter value, 0. The HTML anchor ++, which the user clicks to increase the count, is included as well. Again, this is only a small test example, but as always we can generalize to programs of any complexity. For example, here we test if an expected text is shown at a certain position. And if you want to perform this as an automated test, you will have to navigate through the tree by using @messages. This entry shows what happens when the user presses the ++ button. The Testsuite proxy server can use this request as an automated test at a later time. This concludes our short introduction into the 3 branches of the VisKonz Testsuite. Thank you very much for your attention.